Hello all, very good evening. Thanks for joining the session. Let me share my screen.
Good evening.
Good evening. Okay, so today let us start the CI/CD pipeline and let us understand the need of CI/CD pipeline and the various tools that are required to be integrated in the CI/CD pipeline, right? And first of all, we need to thoroughly understand the concept of CI/CD, why it is required. Okay, so let us try to understand the concept of CI/CD thoroughly with the problem statement, and then let us see the tools that were used in this CI/CD pipeline. And also let us see the CI/CD pipeline importance with respect to the microservices architecture. So all these discussions let us do. Right, now let us go and then see what is the CI/CD pipeline. First of all, in the CI/CD pipeline, so let us try to understand now what is CI, continuous integration. So let us try to understand what is continuous integration and also how to set up this continuous integration. So we will discuss everything, like the support matrix required to set up the pipeline. So everything we will discuss, meaning in order to set up this entire pipeline in the cloud, what are the missions we need to take, configuration of the missions that we need to do, right? So their support matrix like hardware, software, CPU, RAM. So how much memory required for these missions and all we will discuss. First, let us understand the importance of this pipeline. So is this for the developers? Is this for the DevOps? Is this for the testers? So let us derive the conclusion, this pipeline for whom and what this pipeline will do. Okay, first of all, let us try to understand what is continuous integration. Of course, before understanding this, what is continuous integration, let us see the case. Okay, so before understanding this continuous integration, let us see one situation, right? So usually in real time, what will happen? There will be a team of people, right? For example, there will be a developers team, right? And there will be a QA team, right? And there will be a operations team. There will be a operations team. So we have the team of people, developers team, QA team, and then operations team. So what this developers team will do is, developers team will write the source code. Will write the source code to generate the software application. Software application. For example, you might have seen the Facebook. So Facebook is an application, but behind the scene, there were a lot of lines of code might have been written. Code meaning what? Series of instructions, series of lines. For example, if we can see here, we have these applications. So there is a Node.js application. 1 minute. So there is a Node.js application. This Node.js application will have the code like this. See, some coding has been written. For example, some JavaScript file is written. So it contains some JavaScript related lines of instruction. And if we can go and then see some other application, for example, this application, this is a Java application. Some Java code has been written, right? For example, let me show you some Java code. So this is some kind of Java code, right? So this is some lines of instruction. And if we can take a HTML For example, static website, React.js application, if you can see. So this is the React.js application code. For example, let us see this department.js. This is a React.js lines of code, lines of instructions, right? And if we take a static website, so for example, if you can see this static website, there were the static website source code, right? This is the source code. Now what we are calling the lines of instructions which will produce the software is called as a source code, and this source code will be written by the developers. For example, if it is a Java source code, Java developers will write this one. If it is a Node.js developers will write this one. If it is React.js developer will write this one. If it is the static websites like HTML, UI designers will do this one, isn't it? That means UI designers. So UI designers, right, and developers and all will do the lines of, they will write the lines of code. So developers as a team, developers as a team will write the source code to generate the software application, isn't it? So they will write the source code, they will be act as a team and then write the source code, isn't it? So now if you can see in the centralized system, for example, let me take one new diagram. So just let me open the new diagram. So there might be a team of developers, right? So team of developers, there might be one developer might work on, for example, developers group or developers team. Let me take a blank diagram. Fine, if we can take the blank this developers team. So let me take the developer 1, developer 2, developer 3, like that. Let me take. So for example, yes, so this is the developer 1 mission. Okay, so if you can see, so he is the guy who is doing some development. So he is the guy who is doing some development. So this is the developer 1. Similarly, let us take developer 2. So developer 2 is doing some development, lines of code he is writing. Similarly, let us say he is the developer 3. So developer 3 is also writing some lines of code to generate the software. Now what will happen, while these developers are working together as a team, right? While these developers working together as a team, the developer A might require the developer B code. This is we have seen, right? So in usually real time, we will see this. Developer A might require the developer B source code, or maybe developer B source code might require to developer C, right? Maybe developer C source code might again require to developer B. That means in a collaboration mode they will work. In a collaboration mode they will work. So when this guy requires the source code of this person, how the source code will be taken, right? Assume this developer A required the source code of developer B, and developer B required the source code of developer C, right? So this is the developer C source code, right? So developer B required the source code of developer A. Now how this source code will be exchanged? Source code cannot be exchanged over an email, right? Source code cannot be exchanged through the chatting applications. So this source code needs to be exchanged through some repository, right? So in a day-to-day real-time implementations, right, the developers are required to work collaboratively. One developer may require the source code of other developer. So the developer A required the source code of developer B, then developer B source code should not be exchanged to developer A via an email or via chat window applications, or it should not be exchanged like via any other medium. Rather than this source code needs to be integrated. What is this? Someone is drawing along with me. Let me reshare my screen. Please don't do drawing. If you have any questions, raise your point. Fine. So now what what we need to do in order to exchange, or in order to work in a collaborate environment, the source code needs to be exchanged, right? Developer A code, developer B code needs to be exchanged together. For that, what we want a centralized we want a centralized version control system like GitHub. So we want what? We want a centralized version control system like GitHub. Now what will happen? The developer B, once he done his source code changes, he will push to this GitHub, right? And also developer C, once he done his source code, he will push to this GitHub. He will keep the code in this GitHub, right? Similarly, the developer A also will keep his code in the GitHub, right? Now what will happen when the developer A requires the source code written by the developer B? Then what developer A will do? Developer A should have to go to this GitHub, isn't it? Developer A should have to go to GitHub, and from the GitHub, he needs to take the code. And similarly, when developer B requires the code of the developer C, then developer B can get it through this version control system. Likewise, the developers need to work in a collaborative environment with the distributed version control systems called for example, the GitHub. So this is called a source code repository. So now what we understood, the developers will write the code, right? Lines of instructions they will write, like how I have shown you. This is the HTML code, this is the React.js code, this is the Java code, this is the Node.js code, right? This is the JSP code, and this is the XML code. Like that, the developers will write the coding, write the lines of instructions in their local machines, and then they will keep the copy of their code inside this central repository, distributed version control system. Now, what will happen? As a collaboratively, they need to work as a team. So developer B, developer C, if they want the code of the developer A, they can go and then get it from this distributed version control system, right? So by this discussion, what do you understand? The developers will keep the source code in a distributed version control systems, and day to day, they will write a lot of code, right? This lot of code will be day to day. These many developers will write the lot of code, right? Day to day, this lot of code will be keep in this centralized repository. So source code changes will be put in this centralized repository in day to day.
Your voice is a little bit low as compared to a regular. Can you please check your mic?
I think it's problem with you, I believe. Is it problem with all? No. I believe.
No.
Yeah.
Yes, sir. Voice is less.
I think that is for few people. Am I audible for? Is my
Yeah.
no? Actually, yeah.
Yeah, it's audible.
audible.
Yeah,
For us, fine. It's fine.
Correct. Maybe check your mic. Check your mic. Yeah. Thanks. Okay. Now what we understood. Usually the flow is what these developers will keep their code changes in this centralized version control system. So this code, whatever the source code they were written, right? So this is the source code, lines of code they were written. The source code, whatever they were written, the source code need to be come as an application. The outcome of the source code is what is an application. So those need to be come as an application, right? The final output of the source code is what? Application. For example, Facebook, right? Gmail or Google Drive or Outlook, Whatever it is, that is an application. The final outcome is what? Basically, the final outcome is an application. So this is the application. So these instructions now we were written, right? In some programming language, we were written that instructions. So instructions were written in the programming language, but the application can be accessed by anyone and can be self-explanatory. For example, if you can see your Facebook, it is self-driven. You go there, you log in, you see your charts, you see your friend circles, you see your taglines, timelines, comments, videos, whatever it is a self-driven. You go there and then you play with the application self-driven. But in the down the line, maybe in the behind the scene, it has been written with 1,000 tons of code. That code might not be understood by the end users, no need to be, but end users only will understand the application. That means someone should be there. Someone should be there in the middle. Someone should be there in the middle who needs to take the source code written by these developers. For example, developers written source code is here. So someone should have to take that source code and then someone should have to make it as an application, right? For example, this is a component. This is one place. You can consider simply it as a build server. You can consider it as a simply build server. So what this build server need to do is this build server need to take the code, right? This is the build server. So this build server need to take the code. Let me type build server. Yeah. So this build server need to take the code and this code needs to be converted, or maybe this code needs to be packaged as an application. There should be some intermediate person or intermediate component which will take the lines of code written by the developers, and using that it will produce the application which is self-explanatory, right? So this build server will do what basically? This build server will build the source code, whatever the developers were written. So this build server will build the source code, right? And the building the source code meaning what? Comprising. So what lines of tons of lines of code were written, right? This entire code definitely not go as an application. It needs to be compressed, isn't it? Usually when we are sending 10-15 files to someone else, what we will do? We will compress them as a zip file and then send the zip file, isn't it? Similarly, this build as is also a compressed version of the source files. And this build is doing what, this build, once after the build server will compress the source code into a build format. So this build format is called as an artifactory. So it will first do what? It will compress it as a compress and then build it, then will generate the artifactory. Artifactory. So what is artifactory? I'll explain. For now, you will just understand this artifactory will become as an application when this artifactory will deploy in a server. For example, there is a server. So this is the server. So now in the server, this is the server. Now whatever this artifactory generated, right? This artifactory, whatever the artifactory will be generated, right? Maybe jar or maybe var or maybe anything, some artifact. So maybe your Node.js developer, some Node.js thing, some artifact, whatever the artifact it is generated here, that artifact will be put in one server. The server will understand this compressed format of the source code called artifactory and then generate an application, and these application can be used by the end users. So here are the end users like you, me, right? Who will use the Facebook, Gmail and all. So these are all the end users who will start using the application. Now in this entire process, what you understand, developers will write the code, lines of instructions they will write. These developers will put their lines of code into a centralized version control system called GitHub. just like GitHub. There were many, but assume GitHub. And from this GitHub, the source code need to be taken by some build server, and this build server need to be compress the source code into one format, and from that format it will generate one deployable artifact nothing but again this compressed format is only called as an artifact. And this artifact when deploy in a server, another server, assume another machine, you can consider another laptop, you can consider simple. So when it will be deployed in another server, then an application will be generated out of it, and this application will be used by the end users like you or me. This is fair enough flow. Now what is the problem in this flow? What is the problem in this flow? What is the need of continuous integration in this flow? Now let us see the problem in this flow. The problem in this flow is, number one, how this build server will get the code from this source code repository or the version control system. From this GitHub, how the source code will be taken by this build server, right? Assume there is a person called administrator. So who is doing this activity? Just assume. So here is an administrator. What this administrator will do is, the job of this administrator is to go to this source code repository, download the source code and put in this machine, and then build it. Build meaning start comprising it and generate one application related artifact and deploy this artifact in one container. Then an application will be generated out of it. Assume this is doing manually by this administrator. Okay, now what is the problem in this? So assume the case now the developers are day to day writing a lot of files and then putting in this source code repository, isn't it? Day to day, these guys are writing a lot of source code files and then putting here. So as the administrator is here, this administrator really don't know when to go to the source code repository and then get the latest source code from this GitHub and then put in this build server, isn't it? So this person really don't know when to go for this GitHub, download the source code from there and then put into this build server and then build it. So someone should have to inform to this administrator, right? The manual person. So developers, all the developers were busy in writing the lines of code. They were written lot of lines of code related to a different features. For example, this person written a lot of lines of code for the registration system, and this person might have written a lot of lines of code for the login, and this person might have written a lot of lines of code for the dashboard, rendering the dashboard. Once after the user login, the dashboard will display, right? So assume he is working on the feature called display dashboard, is working on the feature called login, and this guy is working on the feature called registration. So these guys will spend these guys were spent 3 weeks of time, assume, and completed their work. Like developer A completed the registration, developer B completed the login, developer C completed the dashboard, and these files were moved to this distributed version control system called GitHub, assume. So entire 3 weeks were gone. Now after 3 weeks, what they were done, they were informed to this administrator, hey administrator, now registration, login and dashboard source code is there in the GitHub. You go and then download these files from the GitHub and then put into the build server and then build it. So these 3 members are 3 developers so far we are considering, right? These are instructed to this administrator. Now administrator did what? Administrator went to this GitHub, downloaded the source code and added the source code, kept the source code on this build server, and some other way he started building the application according to the build documentation given by these 3 persons, right? So these persons will given a document, build a document they were shared. For example, I can say it as, one moment, let me take a document. Sorry, document. Let me take document. So this is the instructions. This is the instruction document they were given. So this is the instruction document they were shared. So this instruction document will be given to this administrator. Now administrator followed the instruction document given by these three developers and executed everything as it is, but found build fail. While building, it failed. While building, it failed. Then administrator did what? Administrator informed back to these developers, hey, I have followed these steps, 10 steps you have given. I followed step 1, step 2, step 3, but at the 9th step, it got failed for me. You go and then see. So he informed back to these developers. Now developers might have written that code in the week 1, isn't it? For example, dashboard, login is giving some problem. Code building, meaning the compression of this login source files is giving some problem. So he informed back to all these three developers. Now 3 developers will start looking into the issue which was written, for which the code has been written 3 weeks back. So they have to go back to their older code and then see the source code and then fix the problem. And then again, they have to keep the files here. And then again, it should have to be informed to this guy, update the deployment document, give the deployment document to this person. Then administrator will start again doing the build. Right, it's not so happened immediately. This will take a lot of time, right? So now, first of all, what are the reasons that this build failed here? Can you please mute, guys? So as soon as you join, please try to mute yourself. Thank you. So first of all, these source code written here, right? When it put on the build server, why it failed? First of all, why it failed? Okay, and that is first question. Why it failed is the first question. Second question is, somehow the developers fixed the problem and then given the code to this. Again, this administrator went to GitHub, downloaded the source code, and then copy the source code to this build server. Again, he started building using the documentation. This time, issue came in the registration, and he informed to registration. Login is working fine. Our build login files got build fine. Build meaning login files got compressed file. Like however a word 10 word files we need to send to someone, we will compress it, right? Like that only. So the files you were written, the login files were compressed, but the registration files compression is giving the problem. Again, the problem came in the registration. Now this person informed back to all 3 developers, and then developer A worked on fixing the registration code issues and then putting into GitHub. Again, this person will go here and then putting onto build server, right? And then again, he will follow the build document to deploy it. In this whole process, what you are understood is 3 things you are understood. Number 1, when developers are pushing the code to source code repository like GitHub, right? They have to inform the admin person to build the source code, by following the document shared by the developers. Number 2, even though the document followed correctly, but but for the administrator, the build failed. This is because what, very, very important. This is because code is merged but not integrated. This is very important statement. Code is merged but not integrated. That is the reason when the administrator is building, he is getting the problems. Right? What is this integration? We will see that one, but code is merged. Merged meaning what? Merged meaning what? So developer A written code, developer B written code, developer C written code will be merged in one repository or one branch here. So we can say we will keep one branch here. This is one branch. In this branch, all the three members code is merged together. So this is the branch. So in this branch, for example, this is the QA release branch. Assume QA release branch. This is QA release branch. Now what is happening? All the developers code is combined together and put into a QA release branch. And from the QA release branch, this administrator is downloading the source code. So the source code of all these three developers is merged, but the source code is not integrated on this build server. What is now this integration? What is now this integration? Right? What is now the integration is, you got the problem, right? You might understood the problem statement. The code is merged. All these three developers code is merged, but the code is not properly integrated with this build server in a right time. That means what? What is integration? For example, developer A, when he write the code and when he keep the code here, if at that moment, if the build server will integrated with this GitHub and the code will be taken to this build server and then it will be built, at that moment only the issue will be resolved. And meaning the week one only, when the login is implementing, at that moment only the issue might be resolved. Now after 3 weeks, the issues are raising in login, issues are raising in registration, issues are raising in dashboard. As a result, the developers need to rework on their code in fixing the issues, isn't it? Which is not expected. Time waste. 3 weeks of time they have spent in developing the code. Again, they are spending 2 to 3 days of time extra in fixing the issues which were raised while building the source code, which is not expected. Time waste, right? So that is the problem we came because of lack of integration. So what is the solution for this problem? The solution for this problem is don't have the manual intervention. First of all, the solution for this problem is establish the integration. Establish the integration first. So what is sorry, what is this integration? So there is a build server, right? Let us keep the build server notify as soon as the developer will push the code into this repository, so that the build server will go to Git repository, get the source code, build it. If any issue will come, it will notify via email to these developers. It will notify via email to all these developers, right? Maybe developer A, and it will also inform to all these developers, developer B. For all these developers, it will inform the build failures. Whatever the build failures occur, these build failures will be informed to all these developers via an email, right? So via an email. So this is one. So like that, it will be informed to all the developers via an email. So at the moment when the developer will check in his code or push his code to this GitHub, the build server, as it integrated with this GitHub, is taking the source code, building it. While building, if any issues will come, it is triggering the email to that respective developer. So the developer immediately on the same day itself can fix the code and then again push it to the GitHub. That's how the issues will be resolved with this continuous integration. Got it? So that's how the issues will be resolved with the continuous integration, and the productivity will be improved. So what is now continuous integration? Continuous integration is an automated process of continuous integration is an automated process of generating the software application code or a particular feature, maybe login registration. So generating the software application code or a feature, right? So it is what? Generating the software application code, generating the software application. So let us say continuous integration is an automated process of generating the software application features, not code. So continuous integration is an automated process of generating the software application features quickly and efficiently. Why we used efficiently? Because there is no manual intervention. How it is quickly? Because as soon as the developer will push the code, if the build server will be integrated with this GitHub, immediately it is taking the code and then building the code and then finding out the issues, notifying the developers with an email, triggering, and also by mentioning the issue, what it is. So on the same day, same moment, the developer will alert and then fix the issue. Again, he will push the code, that fixed code, to the GitHub. From there, meaning the central repository. From there, again, the build server will take it and then build it. So issue will be resolved. Immediately, the issue will be resolved. So continuous integration is an automated process of generating the software application features quickly and effectively. So we need to automate it, not manual. So in order to automate it, we have the build automation tools like Jenkins. So now, rather than keeping a manual administrator here, let us keep the Jenkins administration here. So Jenkins is a build automation tool. So let us keep the Jenkins administration here. Now Jenkins administration will solve a problem of this continuous integration, because the Jenkins have the various plugins that can integrate with any of the source code repository and then pull the source code from this repository and then build it immediately and then generate the artifact. So that capability this Jenkins build server will have. So we were eliminated the manual intervention here. Everything we were automated using this Jenkins now, isn't it? So this is called as continuous integration, right? So it's continuous integration eliminates the manual effort, increase the efficiency, improve the productivity, and also continuously it is integrating with the developer changes. Okay, fine. So this is what now the continuous integration. Now, while doing this continuous integration, the source code which is written by the developers, right? The source code which is written by these developers, while this continuous integration is happening, the source code developed by these developers here, right? This source code might have the vulnerabilities, like they were not followed a proper coding standard, or they were not handled the null pointer exceptions error, or they have not written up to the standard. So source code scanner is required here. So source code scanner is required here. So such a source code scanner we will use as a SonarQube scanner. SonarQube scanner gate we will use in this Jenkins pipeline. So what the SonarQube scanner gate will do, as soon as the source code will come here, and while building the source code by the build tools like Maven for the Java applications, or MSC, or .zip, or any other build tools for building their respective applications. Anything we can use here. So this build tool, while building the source code here, the source code will be smelled. Source code will be smelled for the violations by the sonar quality gate. So sonar cube setup we need to do in our Jenkins pipeline to smell the source code and then to detect the source code policy violations, coding standards, right? All those things it will smell and then fail the build if there were a lot of code violations. That means it is having a gate. It is having a gate, and that gate will control the build artifactory generation. If you can see here, so this is the build, and from this build an artifactory need to be generated. So from this build, while generating this artifactory, we will use here a gate. We will use here a gate, quality gate we will use. So that quality gate will do what? That quality gate will smell the quality of the source code. So here is the quality gate. So this quality gate will smell the source code, and then if the source code is too bad, having a lot of vulnerabilities, then the build will fail and then inform to developers. The source code is good, right? Source code is up to the standards, right? No code smells, no much code smells, then the build will be generated. Now whatever the build will be generated, right? This build need to be put into some server containers. Now how this build will be put into some server containers, isn't it? Right now the source code is smelled by this sonar cube quality gate, and it detected few violations. So build will be failed and trigger an information to developers. Then developers will fix that code smelling issues, again push here, again our build server will take it, again build it, and then again code smell will be detected while building. Now this time the code smell is low, then the build will be success, and then artifact will be generated. Now the question is when this artifactory will be moved to this servlet container. Right now, when the artifactory will be moved to this machine, so this artifactory will be moved to this machine. From the first this artifactory, we need to push to some place called artifactories, maybe JFrog or Nexus. So we have to use artifactories here. So this artifactory we will use here whatever the artifactory we generated, we will push to this artifactory. Now what will happen from this artifactory, meaning this server machine, server machine is there, this will connect to this artifactory and then get the artifact onto its server machine. Now once this artifact is extracted and then executed by this container, it will generate an application. And this application, before reaching to the end users, this application first will be tested by the testers. So for example, tester, let me take quality analyst, right? So there is a quality analyst, or let me take set of users basically. So assume the set of users, right? So these are the testers. The set of testers will do what? They will test the application. They will perform the application testing. So thoroughly they will test this application. Once the application is fine, so assume, let me keep these persons here. So these testers will start testing the application. So they will thoroughly test the application, whether the application have any functional issues. For example, functional issues meaning registration is working fine, but email is not sending. Login is happening, but not going to the dashboard. Some issues, functional issues will be tested by these guys. If the functional issues were resolved, meaning there were no issues, everything is okay, then what we will do, let us maintain one more this servlet container machine, like one more machine we will maintain, and that machine again will take the same artifactory and then deploy here, and then the application will be also generated from that one. Now here one more round of testing will be happened. So maybe this is the quality, maybe this is the user acceptance test environment. So one more round of testing will be happened here. The user acceptance test, real environment. With the real environment, the testing will be happened. So once the testing will be done with the real environment, everything is okay, all the features are working as expected, then it will be moved to the production system from the same RT factory will be also moved to the production system, and it will generate the application. Now this application now will be used by the end users like you and me and so many, right? So this is the production application. Now the production application will be used by the end users. So let's see, this is not. So let's see, these are the end users. So these end users will start using the application, right? So this is a happy path. We were in the happy path. Now everything went good in the happy path. But what is the unhappy path? Meaning the developers were tested the application, but they identified some functional bugs. Then what it will happen? So these testers identified some functional bugs. So what they will do? They will inform this testers group will inform the developers saying that, there were functional issues in the current build, whatever the build is happened, right? That means this build, the build, whatever the generated artifactory, right? So in that artifactory, there were some issues. So these are the functional bugs. Like that, the testers will notify the developers about the functional bugs. Now, when the testers will notify the developers about the functional bugs, then what will happen? The developers will fix those functional bugs, and then developers will again push the source code to this source code repository. So once these testers will inform these developers will again tweak the code and then push the code to GitHub, and then GitHub again build server will build it, and then artifactory will be generated. It will be put on to QA server. QA server app will be generated, and again this will be tested by the testers. So unless the testers will give the green signal that this build is okay, whatever the artifactory which is there now in the artifactory or in the QA server, right? That is okay, that is a proper. So then when say give the green signal, right? When they certified the current artifactory, then that only moved to this next level of infrastructure. For example, the UAT environment, and there again it will be tested with the real seamless environment. Once this is success, then it will be go to the other production environment. So this also need to be a continuously. This also need to be happened continuously. So this is called as continuous deployment. So this should be happen as continuously. So this is a continuous deployment. So this is how we need to do. So if you can see here, throughout this entire this process, how many members came here? Meaning developers came here, and the testers came here, and here the build server need to be installed and then set up, right? So operations guys came here. So here infrastructure need to be set up, right? Infrastructure need to be set up, meaning installing the machine, Linux machine, installing the softwares, installing the dependencies, finally connecting to this artifactory, and then downloading the artifact, and then running the artifact in a server. These are all the things, at least the setup need to be done by the operations guys. So if you can clearly observe, this entire process has been involved by the developers, and then involved by the testers, and then involved by these operations engineers. So CI/CD pipeline is good to know for all the members who are the developers, who are the testers, who are the operations engineers. For all of you, the CI/CD pipeline is important to know. Now, what are the various tools that will be used by the developers here, and then the tools used by the operations engineers, and then tools used by these testers? For example, especially in the code pipeline, if you can see, what are the tools that we got is, if you can see, so the source code which is there in the GitHub, right, need to be taken by this build server called Jenkins. Now here we will have a quality gate called SonarQube, and once everything is okay, build success, then the artifact will be generated and moved to Artifactory. And from the Artifactory, the artifact will be taken and then run on a Docker machine. So to the Docker machine, this artifact, this Docker machine will connect to this Artifactory and take the artifact, and then using that artifact here, Docker image will be prepared. So for that, Ansible will be here. Ansible will take the Docker files from the Git repository, and then first Docker file is here. Docker file will be taken by the, okay, first developers will write the instructions in the Docker file. Keep on this GitHub. From the GitHub, the Jenkins will take, and Jenkins will hand over it to Ansible machine. And now Ansible machine will connect it to Docker machine, and using this Docker file plus using the Artifactory. Using these two, it will generate a Docker image and put into the container registry. So till here we will cover in this CI/CD pipeline. And as a deployment, whatever the Docker image we got, right, that Docker image will deploy in one Docker environment, another Kubernetes. Of course, for the CI/CD pipeline, the guys who are joining explicitly for the CI/CD pipeline, for them the Kubernetes is not covering, but whatever the image is built here, that image we will run in some cloud platform. Okay, for example, mostly Kubernetes only, let us assume, but Kubernetes in depth, Kubernetes I don't touch for you guys. Okay, so now, so Docker files are written by these guys, right, and put into the Git repository, right? Why the Docker files are put into here? Because any changes the developer will do, right? So the Docker files also keep as part of the source code. For example, what I would like to tell you is, let me open the existing Git repository where we used it for the earlier batch CI/CD pipeline implementation. Just let me showcase that. So I would like to go here, and here is my repository, is the morning DevOps one. In this repository, if you can see, here is the source code. Here is the source code. Can you please mute? Can you please mute? Yeah. So here is the source code. Now, if you can see source code, there is a Docker file. Now this source code, when it built, it is taking by the Jenkins. For example, if you can see here, webhooks. So it is taking by the Jenkins. Now, what do you understand? The source code, whichever we are putting into this repository, that is now taking by this Jenkins. So that means, if you can see here, so this integration is happening. Jenkins and then Git integration is happening. There are various ways to do that, I will explain. But the Docker file will be in the Git repository, and then it will come to this Jenkins. From the Jenkins, it will be moved on to the Ansible machine. So if we can go here again, the code. So once the code is built, we will write a deployment strategy. So in this deployment strategy, of course, as part of this code build, if we can go here, we also were written one playbook, Ansible playbook. If you can see this Ansible playbook, what it is doing, it is connected to Docker machine. Sorry, it is connected to Docker machine, and from the on the Docker machine, it is executing the Docker commands to generate the Docker image and then push it to the container registry. So what do you understand in this entire flow? What do you understand is, so there is a continuous integration between the source code repository and then the Jenkins. Whenever the developer will do any source code changes or file changes and push to this Git repository, and when the code will be merged with this Git repository, then the Jenkins will pull it, and then Jenkins will build it, and then the Artifactory will be moved here. Files will be moved to Ansible. Now artifact will be taken into the Docker, taken by the Docker, and then the Ansible will have the configuration files. Now Ansible will connect to the Docker and then execute the Docker file plus the artifact which is taking from the artifactory onto this Docker. So it will execute and then prepare the Docker image. Docker image will be pushed to the container registry. And later runtime from the container registry, we can take and then deploy everywhere we want. For example, Kubernetes, if you have, you can deploy it in the Kubernetes. Or if you don't have Kubernetes, if you have another machine, the Docker machine, which is acting as a production server or QA server, you can deploy and then run there, isn't it? So this is what the CI/CD pipeline and then the tools that were covered entire this course, right? So do you have any questions now? You can ask me.
Sir, I have one small question, sir.
Yeah, please.
Sir, so I'm understand like 90%, 10% of my question like previous slide. So in the Docker, they're using like server contents, like the servers.
Server container, we can say. Yes, correct.
Yeah, a physical server, like Linux machine, something. Yeah.
Correct.
So instead of Linux machine, so the what you're saying, that slide is showing the Docker engine, correct?
Correct. Here, Docker will come. Ultimately, Docker will come here.
Yeah, so Docker. Okay. So here is showing tester, right? So tester that will be image is the code goes to the applications, the application tested by the testers.
Correct.
On that slide, I didn't understand where tester comes on that slide, sir. That is my first question.
Okay. So basically, in any organization, testers will be there, isn't it? For every project, testers will be there. So once the application will be deployed and then application will be run in the server, then what these testers will do, the testers will access the application and then they will test the application. For example, functional testing they will use. For example, you can see, let me open the application just in a moment. What the application it will run is, just in a moment, let me run this simple application. Not simple application, it is a realistic application. Let me run this one. Just I will show you. Now this is the application which will run inside this server container. Now once the application is started, once the application is up and run, then this administration or ops people, operations guys, these are all doing by the operations guys, right? Operations people will inform to the all the team members like developers team, testers team, saying that the application is deployed now, you can go and then use it. So when the application is deployed and when the application is able to use it now, and the testers will come and then they will start using the application. For example, they will access the application like this, localhost :8087. So for them, now the application will be opened. So what they will do is now they will access this application, click on the login, then let me go here, click on the login, or maybe click on the sign up. So I think it is not happening. For example, they will go and then log in. Assume they will directly access the dashboard. Right now the dashboard will come. So what they will do now inside the dashboard, there are functionalities there. For example, departments creation, doctors appointments creation, doctor schedule creation. So there are various functionality. Now testers will do what? For example, one tester is testing this departments creation. So I'm just clicking on it. So this tester will do what? Add department, for example. They will do the testing now. What happens if we don't give the department name, only give the department description and create department? What will happen? If I give the department name and I don't make it as active or inactive, what will happen? So like this, with the various negative scenarios, they will test the application. If this feature is working without even entering the department name, if the department is creating, that is a bug actually, because without department name, how the department will be created, isn't it? So they will write a test case for it and they will log a bug for it. And like that, they will test everything. For example, doctor module may be tested by one more tester, assume. So while adding the doctor, maybe there are several cases. So email is keeping as mandatory, but email is not unique, right? Maybe see here, this date of birth, this date picker is not working and the departments are not populating here, right? Assume without giving the first name and then even the username doctor is creating. So these are all the negative cases, scenarios that testers will do the testing and then inform it to the development team along with the bugs or issues that they were identified. Got it? Huh?
Yeah, got it, sir. And so what about that the first slide showing like that the developers are yeah, no, another slide, next slide, sir. Another one. So here showing like in that Git beside developers there, right? So you took like he has some content Docker, so he putting some code inside Docker. So
no. He have the source code plus Docker file. Both he will have. Okay, he will write the Docker file. So the source code plus Docker file he will put into this Git repository.
Okay. So file they Docker file I keep to the Git repository.
Git repository, Docker file plus source code, both he will keep inside the Git repository. Okay. So this is what, if you can see here, source code is there plus Docker file is there. Source code is there, Docker file is there. Both are there inside the Git repository. Now our build server, that is the Jenkins, will take the source code plus Docker file. It will use the source code to generate the artifact. Artifact meaning like this. See this var. The var is now called as an artifact. So this var will be understood by this servlet container, what I have written here, server containers. So the server containers will understand this var file. And from that var file only, if you can see, I just have run this var file. I have given one command here. So if you can see, Java space -jar, some command I have given. So this is the artifact. So this is the artifact. Now when artifact will be run, application is generated, isn't it? Now we access the application. So artifact meaning a var file or jar file. Using this artifact, now if you can see here, the Docker is there. So Docker file is there. Now what is this Docker file is using? Docker file is using this artifact, and then whatever the command I have given, Java space -jar. This command is now given by this Docker itself, so that this application will be run when the image will be created and then running as a Docker container. There is a concept called image, Docker container and all. So those will be discussed moving forward. At this moment, it is very tough concept, but moving forward, we will understand. So this Docker is our runtime, container runtime, where the artifact will be dumped here, and then the Docker file will be moved here. Both will together generate the Docker image and then run the application here.
Okay, so Ansible helps to that run that Docker file.
Ansible will helps to connect to this Docker machine, copy the Docker file to this Docker machine, and execute the set of commands on this Docker machine. So Ansible is used to connect to this Docker machine and execute the set of instructions on the Docker machine. That means Ansible machine will connect to Docker machine, meaning we never go to Docker machine physically. It is automation. Ansible machine will connect to Docker machine, and Ansible machine will execute the commands on this Docker machine to generate the Docker image. So here Ansible is acting as a configuration server. Okay. So
for connecting the Dockers.
Connecting and then copying the files, executing the commands, executing the packages, removing the packages from the Docker machine. Lot more thing it will do. Okay.
Yes.
Yeah.
Like I have one question here. Like as you said, the developer is going to check in this Docker file and Docker compose.yaml file as well when I see this repository.
Correct.
Yes. Yes. So without an image, the YAML doesn't work.
Exactly correct. Without image, YAML doesn't work.
So as part of the can you go back to that slide one more time?
Sure.
So here, as part of the Jenkins, it will prepare the executable jar that is going to be pushed into the artifact repository. Is it?
Correct. Exactly correct.
Okay, that will push into the repository. So after that, it will give a handshake to the Ansible. Ansible is going to move the Docker file into the Docker and prepares the image and prepares the image where it's going to be keep that image.
Correct. So it will connect to this Docker machine And then in the Docker machine, it will connect to Docker machine. Sorry, my bad. So it will connect to Docker machine, copy the Docker file to here, create the image, and also copy the Docker compose file here, and create the container using.
Yeah, while creating the image, it needs an executable jar file, right?
Correct.
So that executable jar file is exist in the artifactory management, right?
Exactly.
So how it is going to be bring it from there?
There is, we will write the script actually. It is a URL. So every artifactory will generate one URL for the artifact that we pushed here. So we will use that URL here using the wget command and then download that.
But and the Docker file, will it accept the URL?
No, it will not Docker file will accept the URL. So what we will do is, for example, Docker. So here is this is the Linux machine. Docker machine is Linux machine.
Docker itself is a Linux machine. First, we are going to fetch the repository into the system, and then we will run the Docker file.
Exactly correct. Exactly.
Okay. And once the image is prepared, are we are keeping here, or we are putting in the container? It's a private repository.
Correct. It's a private repository. I will explain the ECR. AWS Elastic Container Registry. I will explain. So GitHub I will explain. Sorry, Docker Hub I will explain, and then Elastic Container Registry ECR I will explain.
So generally, which one they will use? Like mostly.
Mostly private repositories only. We have to prefer only the private repositories. For example, ECR is there for the AWS. If our entire infrastructure is setting up in the AWS, then we can use a hosted registry called ECR, but it is chargeable. So if you don't want chargeable, if you want a private repository, but it is free, then we can go for the Harbor. So here we can use Harbor as our open source private registry. So let us take one more EC2 machine, set up the Harbor as a registry. So from the Harbor, any of the infrastructure can get it.
Okay, like I understand. Like when we are using this these repositories, like will there any differences between when we are using Docker Hub to Harbor or ECR?
100%. Differences meaning differences in their security. Here actually, of course, Docker Hub
will be same.
Procedure will be same. Yes, correct.
Okay, whatever we are doing the Docker push, it's the same.
Same.
Okay.
Same. Got it. Yeah. Any more questions? So it is really.
Yes, hi Narsi.
Yeah, go ahead.
Yes, hi Narsi. Subham this side.
Yes, Subham.
Yes, actually, I have a question regarding this Jenkins pipeline. When we are going to create this pipeline, so which type of pipeline you are going to create? Is this will be a freestyle job or using Groovy script? You are going to create a declarative pipeline.
Correct. So to answer your question, I want to open this Jenkins file. So see this Jenkins script. What is this? Declarative. Okay, declarative. Groovy script we are using here. Declarative pipeline with the Groovy script we are using. And then it is called as a pipeline as code, PAC, pipeline as a code. The beauty of it, what when any change required in the pipeline, for example, I want to connect to this Ansible machine. Now I want to connect to one more machine. What I can do, I never go to this Jenkins machine. Rather, I will go to this Jenkins file, which is in my repository, and I will establish one more connectivity. So one more stage I will write. I will establish one more machine connectivity and then push it. Then our Jenkins job will take it and then connect to that machine accordingly. Without touching the Jenkins pipeline, once configured, we should not touch. Without touching this, whatever the configuration required for it, we are supplying from the declarative file called Jenkins file. So this is the real-time standard. We have to follow in real time. Also, we will do the same real-time standard. Okay.
Okay, got it. Thank you so much.
Yeah. So Neha, you raised your hand. I don't know whether you are still there or not, but since long time you raised your hand and then you want.
Like I didn't see the Git class one which you are following in the class, right? That one is not uploaded.
You mean the recording?
Not recording. I mean the document.
Notes.
No. The one which you are referring the document, right? There is a step-by-step process, and it explains that, right? That is not uploaded in the classroom.
Yeah, I was not uploaded. I will upload once after this one.
Yeah, like we can practice by seeing those steps, right? So that's what
As correct. Sure, I will do that. Any more questions? So the CI/CD pipeline tools will be there for the 45 days. And what we will cover in this 45 days, Jenkins at an administrator level we will cover, and SonarQube will cover JFrog and the Nexus. Both artifactories I will cover, and then Ansible I will cover, Docker I will cover, container registries I will cover. I mean Harbor we will set up, and also we will do the ECR container registry. So this entire pipeline will take 45 days for you. And then the guys who is joining for this pipeline only, I believe you know the fees and all, but I would like to just give a heads up, like this will take 45 days. Jenkins itself will take 3 weeks. 3 weeks. Docker will take 2 weeks. Here only we completed the 5 weeks, meaning around 1 month plus 5 days, 1 month plus 7 days, 6 days we are completed. The rest of the Ansible will take 1 week. Container registry will take 2 days, meaning 3 days total. JFrog will take 1 day. Nexus will take 1 day. SonarQube will take 3 days. So entire pipeline will take 45 days with the tools, whatever I mentioned, till Docker only. Again, Kubernetes is separate. I will discuss later on it. Yeah,
Hello,
Sindhura, yeah.
What is the role of Maven and how it is different from Jenkins?
Okay, so the Maven, so Jenkins is using what actually? Jenkins is just getting the source code from this Git repository. Now, once after the source code, it will get, meaning whatever the source code that we have now here in this branch, na, see this SRC and all, SRC, all the source code, right? Similarly, the source code will be copied onto this Jenkins. Now that source code need to be built as a artifact. So who will build it as an artifact? Maven will build it as an artifact. Okay. So Maven will be built it as an artifact. Whatever the source code we have, that source code will be built as an artifact by the Maven. Got it? Huh?
Okay, thank you.
Yeah, thanks. And total how many days? Yeah. Go ahead. Please go ahead.
Hi, Narsi. Actually, I don't know whether I'm in the right class or not. I don't know. But yesterday you were explaining about GitHub, right? So
correct.
Actually, I'm not sure. So that's the reason I just wanted a clarity from you.
So we were completed the GitHub by the yesterday, isn't it? Meaning you guys who are joined for the pipeline, for them the GitHub is not there. Okay, I'm starting from the Jenkins only. For the guys who joined for the pipeline, for them I'm starting from the Jenkins. Of course, the Jenkins needs to be integrated with the Git, right? So I will also explain a little bit about the Git, because Git is required, Git also required actually. So I'll explain a little bit about the Git push and then pull process and all. Then the code will be from the Git repository, the code will be come to this Jenkins machine. How it will come, I will explain. So from here, it will be like a pipeline continuation will be go on. So okay. Meaning, got it? Huh?
Okay, you're saying that, okay, the whoever is joining today will be joining along with us for this Jenkins, from this Jenkins you're telling that.
Correct.
Okay.
From here you will go, from here, Jenkins, SonarQube, Artifactory, Ansible, Docker, and registry. So these are all the things you will do. Yeah.
Okay, got it. Thank you.
Yeah. So the fee is, I believe, 6,000 for it, and then duration is 45 days. Timing is 8 p.m. to 9:30. Documents will be provided, material will be provided, and then the videos will be provided for 6 months validity. Okay. So, and the morning hours, I'm not starting at this moment. The morning hours, it will take little time to start the same DevOps in morning hours, but yeah, course completion certificate they will give. Institute will gives you the course completion certificate. Okay, so that's all for today, and tomorrow without late, let us
Hello,
start.
Narsi. Actually, yesterday I think we were on GitHub part and you did not complete the GitHub, right?
GitHub, I was not completed the.
Sir, your voice is very low. Can't hear you.
Yeah, I was not completed the push and pull part, right? So GitHub I introduced, and Git we have done, merge we have done, pull and push part we have not done. That I will explain as part of this Jenkins. So others also who joined for the Jenkins also know that, and you people also get be covered. Got it? Huh?
Yeah, Narsika, please upload that Git the documentation what you are following it.
Okay.
Yeah, right away. I will upload after this session, right away.
Sir, what about that Windows administrator? They can able to handle this kind of environment like in Linux if they want, if they know basic Linux.
Yeah, they can do it. Basic Linux meaning, of course, Linux is required. Little bit, at least SSH level is required. Actually, how the missions will be, missions certificates creation, public-private key certificates exchanging, users creation, granting the permissions, right? Then the copy the files from one machine to another machine. This knowledge is required.
So do you take that basic class of the one day of these things?
Okay, however, we definitely will do those things only here. So whenever the situation come, I will explain that, and then only we will do this. For example, we need to copy the files from Jenkins to this Ansible. So while copying, we need to generate the private key, public key here, public key need to be copied here, and then we have to access this Ansible from the Jenkins. All those things I will explain. Okay.
One question that without Ansible we cannot connect to directly to the Docker also is the Linux system, right?
We can connect.
In the middle, Ansible, we are why it's become that popular. Like, see, from the Jenkins, how we are connecting to the Linux box, we can connect the same way. But why we are using Ansible?
Linux, this is beautiful question. Why we are connecting using Linux here in Ansible here? Ansible have a beautiful feature called parallel processing. For example, Jenkins would like to copy the files to 10 machines like Docker Dev, Docker QA, Docker Dev, we have again 3 machines. Docker QA, we have 3 machines. Docker Prod, we have 3 machines. Docker UAT, we have 4, total of 12 machines need to be updated with the source code or maybe the Docker files copying. Then Jenkins will do what, synchronous process. It will go connect to machine 1 and then copy, then go to machine 2, copy, go to
But
machine
we can
3,
execute the Jenkins as a parallel mechanism also, right? Parallel, yeah.
No, Jenkins jobs are parallel. But what Jenkins can do a connectivity with the other system, it is not parallel. Jenkins jobs are parallel, right? Any number of jobs we can execute parallelly here, right? So each and every, assume the job 1 is connecting to the Docker dev machines, where are 3 Docker machines we have, assume. And one more pipeline we will write, which will connect to the Docker QA, and one more pipeline connected to the Docker prod. Like that, 4 jobs we have to write here. And each and every job will again execute synchronously with the Docker, meaning job 1 connected to Docker machine 1, copy the file, then connect to Docker machine 2, copy the file, then connect to Docker machine 3, copy the file. That itself will take a longer time. For example, copying is taking 2 seconds, and each and every machine is taking 2 seconds. So copying onto dev Docker, it is taking around 10 seconds or maybe 1 minute or 10 minutes as well, based on the connectivity issues and all. But Ansible will do what, in the middle, it will at a time, parallelly, at a time, it will connect to all the missions at a time, it will connect, and then on all the missions with a single command, it will execute on all the missions. For example, here it have a Ansible copy. Ansible copy will execute for all the missions, because Ansible will have an inventory of all the missions. So in the inventory, how many missions were there? To all those missions, it will connect at a time, and then apply the command on all the missions at a time. So time will be saved, faster time will be saved.
Okay. Like big production environments, there we can hundreds of missions are there, then Ansible. Okay.
Exactly. It is a infrastructure as code, ISC. Infrastructure as code. I'll explain going forward.
But maintaining of these codes, right? Like whatever the scripts we are maintaining and all those things. Like as I understand, like Terraform, we are provisioning the infrastructure. Like Ansible also, we are writing some scripts. So those things from where Like, are we are maintaining anything, or how it is? Like, how in the real time they are going to maintain all these things?
Okay, in real time, actually, everything will be nowadays doing by the Terraform. Terraform is the cloud agnostic tool. For example, if our environment is only the AWS, then we have a cloud formation, which will do the infrastructure setup in the AWS only. But if today now AWS, tomorrow I want to go to Azure, maybe one customer asked my product to set up on the GCP. In order to connect to any cloud, we have to use the Terraform. Terraform is like, cloud agnostic, cloud native. So that is one thing. And Ansible will be used. Ansible also doing the same, like, infrastructure setup. Mostly for the on-premises, or mostly for the ad hoc connections, like mission-to-mission connections, the Ansible will be preferred. Cloud-to-cloud connections, meaning cloud infrastructure provisioning and all, we usually do with the Terraforms. And Ansible also can be do, but Ansible need to write a lots of series of executions, meaning lots of codes, and it is preferable for only for the on-premises setup. Got my point, right? Yeah.
Are you going to teach Terraform also?
No. That is AWS. DevOps with AWS guys who are joined my DevOps course, right? For them, yes, I will teach the Terraform. Go and then see the course content. Terraform is there in your course content. Who joined for the DevOps, right? For them, Terraform is already there in your course content. Go and see in our DurgaSoft site, you will see that. That will be covered. And the CI/CD pipeline tools who are newly joining, right? For them, the Kubernetes is not covered. Please refer the course content. Kubernetes is not covered. Kubernetes I will cover. I'll start it separately, because this itself will take 1 month of time. Kubernetes in-depth discussion we will do. It will take 1 month of time. Okay, right. Yeah. If you're part of DevOps, yes, Kubernetes will be explained, and then Kubernetes will be spent for 1 month. We'll spend here 1 month. Multi-node architecture, high availability, what is that? Fault tolerance, zero downtime, canary deployment, blue-green deployment. A lot of concepts are there. RBAC, role-based access control. Lots of concepts we will deal here. But that is last stage. Meaning we are about to finish our DevOps, right? After completion of this DevOps, once the image is ready, then we will go for this Kubernetes. We want the images, Docker images for this Kubernetes. Okay, yeah. Okay, the course content is there in the DurgaSoft website. If I'm not wrong, you can see the DurgaSoft online. The course content might be here. Let me check quickly. If not there, then I'll ask them to upload the course content here as well. For example, CI/CD pipeline, if you want to see. CI/CD, yes, CI/CD pipeline, course content. It might have course content, scroll down. Yes, DevOps lifecycle, CI/CD tools, Jenkins installation, and then the Jenkins security, Ansible, Docker, and then the networking, SonarQube, Nexus, JFrog, right? Here it is. Go and then see the course content in the DurgaSoft online. Of course, our DevOps course content is also here. You might have know already by this time. DevOps course content is also here. So DevOps, let me search with my name, and the way back we started, right? So, oh my God, DevOps is not here, not showing. It seems to be. It is started right way back, so it is not showing here. It seems to be, but DevOps course content also will be in this. Otherwise, I will, of course, DevOps guys, no need to worry about the course content. You know, classroom, and our classroom also we have it.
So you already started DevOps classes, sir, or you have to start?
No, DevOps already started. DevOps classes already started, and then we completed this Git. Completed meaning 50% of it completed. So DevOps tools, actually CI/CD pipeline tools now starting. But before this, we completed the Linux, and the Linux prerequisites we completed, and then we completed the Git 50% we completed. and then coming to the CI/CD pipeline. So who know the Linux basics and who have an idea on the Git, or who don't have an idea on the Git also can join, right? So actual DevOps is started from here, if I could say. Whoever would like to join DevOps, you can join, but DevOps fees is different.
Yeah. So can you give the Linux video session, sir, if you are already completed?
Yeah. They will give.
Yeah, sure, sir. Yeah, I will check.
Okay. Yeah. Okay,
Sir,
folks. Fine.
sir,
Yeah.
Yesterday,
Please.
yesterday you explained the local repository in Jenkins.
No, Pravalika. Yesterday we have seen the Git repository. Na? In the Git repository, I explained the
Git repository in local.
Correct. Yes.
Yeah. When are you planning to complete the remote repository in Git?
We will complete tomorrow. Let us start Jenkins, right? So this Jenkins required to pull the source code from the Git, right? So again, we will come back to Git and then complete that distributed remote repository.
Okay.
Yeah.
Thank you, sir.
Yeah. Okay. So that's all for today, folks. Again, let us come tomorrow back and then start Jenkins without late. Jenkins, what is that? Jenkins client server architecture. So it is beautiful. You enjoy it actually. Jenkins is really beautiful, very easy. You enjoy it. Okay. So let us see from tomorrow onwards. Thank you so much. That's all for today. See you tomorrow.
Thank you, sir.
Thank you.